Good evening, everyone. So today we are going to discuss about continuation class of our feedback amplifiers. Okay. So in continuation we are discussed about multi-stage and feedback amplifiers. Okay. So in our last class we are discussed about what is meant by feedback and how many types of feedbacks are there. Okay. And what is the difference between positive feedback and negative feedback. Okay. So while coming to the feedback, once I would like to revise last class topics, what is meant by feedback. Okay. In feedback, the fraction of output is connected back to the input is called feedback, like this. If we connecting something output back to the input, then that is called what? Feedback. Okay. In amplifiers, if we connect the fraction of output back to the inputs, that is called feedback. So while coming to the types, feedbacks are of mainly two types: positive feedback, negative feedback. So while coming to the positive feedback, this feedback signal is in phase with the input signal, then the feedback is called positive feedback. If in the feedback signal is out of phase with the input signal, then that is called negative feedback. Okay. So mainly the feedbacks are of two types. Okay, positive feedback as well as negative feedback. Positive feedback means if the input signal is in phase with the feedback signal, then that is called positive feedback. If the signal is out of phase with the signal, then that is called negative feedback. Okay. Okay, while coming to the types of feedbacks, negative. So in negative feedback, the input signal is in out of phase with the feedback signal, then that is called negative feedback. So while coming to the expression of gain for the negative feedback, so here in expression, first we would like to draw our block diagram. Okay, then we are drawing the expressions. So once I would like to revise the expression for the feedback. Okay, so in expression for the voltage gain for the positive feedback is came from its diagram. So this is the diagram, this is the input voltage, and for example this is the source voltage. Okay, input voltage is equal to the source voltage plus feedback voltage. So and this is the input voltage and this is the output voltage. While coming to here, it is feedback network. It is indicated with beta, and this feedback voltage is represented as beta into V naught. Okay, beta into V naught. So Vf is equal to beta into V naught. But here, what is the expression for gain? Gain is equal to output voltage by input voltage, and the output voltage is equal to A into Vi. Here, gain A into Vi is equal to what is the Vi? So Vs plus or minus Vf. But here, what is Vf? Vf is equal to beta into V naught. So after simplificationing this equation, what we are getting here, output voltage by source voltage is equal to A by 1 plus A into beta. So in this way, the gain with feedback must be reduced. Okay, and in our last class we are also discussed about the differences between the positive feedback as well as the negative feedback. So already I said that in positive feedback, the difference between are the input signal and feedback signal maintains in phase, that means 0 or 360 degrees. So here the input signal or the feedback signal is in phase with the input signal, then that is called positive feedback. If the input signal is out of phase with the feedback signal, then that is called negative feedback. So here the phase shift is 0 or 360 degrees. Here the phase shift is 180 degrees. Why? Because it is out of phase now. And here while coming to the positive feedback, it is used in oscillator. Why? Because if any circuit acts as a oscillator, it must and should obey the condition of it produce 0 or 360 degrees phase shift. Why? If any circuit is having 0 or 360 degrees to work as an oscillator means it is a circuit that is used to produce an oscillation waveform. So oscillation means it consisting of positive half cycle as well as negative half cycle. Finally, to getting one positive half cycle and one negative half cycle, it must and should consisting of 360 degrees, positive 180 degrees as well as negative 180 degrees. Total it requires 360 degrees. So here this total 360 degrees came from our positive feedback amplifier. While coming to the negative feedback, it consisting of only 180 degrees. So cause of positive feedback having 0 or 360 degrees phase shift, it is used in oscillators. Is it clear? And while coming to the negative feedback, it having only 180 degrees phase shift, so that it is used in amplifiers. And cause of positive feedback, voltage gain is reduced and input impedance, output impedance, all factors must be reduced. But while coming to the negative feedback, voltage gain is increased, input impedance and output impedance must be reduced. What is the advantage of negative feedback? Means it becomes stable. Okay, so these are the differences between the positive feedback and negative feedback we learned in our last class. And while coming to our last class, one more thing is there. According to the connection, the amplifiers are classified into 4 types. One is called voltage, other is called current amplifier. So here voltage amplifiers means based on the connection. Again, these are classified into voltage series amplifiers, voltage shunt amplifiers. Again, current series amplifiers as well as current shunt amplifiers. So in our last class, we are also seeing these diagrams. Okay. And now we are going to discuss about today's class topic. So that is negative feedback, effect of negative feedback and gain. So in our last class, we have discussed about feedback, what is meant by negative feedback. So feedback means connecting fraction of output back to the input is called feedback. Okay. And while coming to the negative feedback, if the feedback voltage is in out of phase with the input voltage, if for example, this is the input voltage and this is the feedback signal. If these two signals are in out of phase, then the kind of feedback is called what? Negative feedback. So here in today's class, we are going to give the expressions for the mathematical expressions for the gain of negative feedback. See here the gain with negative feedback is given by AF is equal to A into 1 plus A beta. What is there? AF means gain with feedback. So AF indicates what? A indicates gain, F indicates when. So totally AF indicates gain with feedback. So that is equal to what? AF is equal to A by 1 plus A beta. So see here AF is equal to gain with feedback. A is only gain. Okay, and here beta is the feedback factor. Is it clear? And here for effective feedback, A into beta is very greater than high 1 unity. Okay, for effective feedback, AB is greater than 1. Hence, 1 can be neglected as compared to A beta in the above expression. So, AF is equal to A by A beta, that is equal to 1 by beta. The feedback circuit usually consisting of resistive elements. Okay, the feedback circuit usually consisting of resistive elements. So that the overall gain depends only on the feedback fraction beta, that is the feedback circuit characteristics. Okay, the gain with negative feedback is given by AF is equal to A by 1 plus A beta. For effective feedback, A beta is greater than 1. Hence, 1 can be neglected as compared to A beta in the above expression. Is it clear? So that if it is neglected, AF is equal to what we are getting? A by A beta, that is equal to 1 by beta. And the feedback circuit is usually consisting of resistive elements. Therefore, the overall gain depends upon the feedback fraction beta, that is the feedback circuit characteristics. Okay, therefore, the overall gain depends only on the feedback fraction beta, that is the feedback circuit characteristics. And see here, while coming to the next one, because of it is depends upon the resistive elements. These resistive elements are unaffected by variations in temperature. Okay, these resistive elements are unaffected by variations in temperature. So that frequency and transistor parameter, and hence the feedback fraction remains stable. Why the negative feedback becomes stable? Why? Because it consisting of resistive elements. And these resistive elements are unaffected by variations in temperature. These are unaffected by temperature. If these are affected by temperature, automatically the parameters becomes unstable, the circuit also becomes unstable. But here we are working with resistive elements, and these are unaffected by variations in temperature. These are unaffected by variations in temperature. Okay, and this frequency and transistor parameters. Okay, so the feedback fraction remains stable only. Stable means it's not movable, not oscillating, constant. Hence, the gain of negative feedback amplifier is very, very stable. Okay, and while coming to the next one, see here, effect of negative feedback on bandwidth. How the negative feedback will affect the bandwidth of amplifier. While coming to the effect of negative feedback on bandwidth, so once we revise what is meant by bandwidth. So what it indicates. So see here, generally band indicates range or group. So here bandwidth indicates the group of frequencies or certain range of frequencies. Okay, so here the bandwidth in amplifier indicates the group of frequencies. The group of frequencies, they attain 70.7% of its maximum gain. The range of frequencies at the group of frequencies, they attains 70.7% of its maximum gain is called feedback. Okay, so the range of frequencies, if they attains 70.7% of its maximum value, is called bandwidth. So while coming to the bandwidth of amplifier, without means negative feedback is given by bandwidth is equal to f2 minus f1. Bandwidth is equal to f2 minus f1. So once see what is meant by f2, what is meant by f1. Okay, so if this is the frequency response and here it is f1 and here it is f2. So here f1 indicates upper cutoff frequency, f2 indicates lower cutoff frequency, like that. F1 is lower cutoff frequency, f2 is upper cutoff frequency. Okay, so this is a diagram, see like this, f1, f2, and this is a lower cutoff frequency and this is higher cutoff frequency, and here it is voltage gain that is indicated with AV. So if the curve that must be drawn between the voltage gain and frequency is called what? Frequency response. Okay, so in the frequency response curve, okay, in frequency response curve, the range of frequencies or the band of frequencies, okay, they attains the 70.7%. How much it is? 70.7% of its maximum gain is called bandwidth. Okay, so now here while coming to the effect of bandwidth with negative feedback, means by application of negative feedback, whether the bandwidth must be increased or the bandwidth must be decreased. So how the bandwidth must be increased or decreased? If the upper cutoff frequency or lower cutoff frequency maybe must be varied, then the bandwidth must be changed. So what is the reason for changing the upper cutoff frequency and lower cutoff frequency? Means here the gain must be, the frequency must be either it may be constant or it may be increased or it may be decreased at a particular gain. So it must be depends upon the transistor parameters. Why? Because here amplifier is a semiconductor device. So semiconductor device, the properties must be varied with temperature, so that if is there any variations in the temperature, automatically the bandwidth must be either increased or it may be decreased. Why? Because cause of instability, or if the parameters of transistor is depends upon the temperature, that means if the temperature is increased, the leakage currents also increased. Automatically when the leakage currents are going to increased, self destruction of the transistor occurred. Self-destruction means thermal runaway. So when the transistor fall into the thermal runaway, automatically the frequency of that particular transistor or amplifier may be increased at certain gain, or it may be decreased at certain gain. The increasing or decreasing or constant range also may be varied. Okay, and now we are discussed about how these increment or decrement or constancy must be changed with the feedback. Okay, so bandwidth of amplifier with negative feedback, so see here, with negative feedback what it happened. So with negative feedback, before going to discuss negative feedback, the expression for bandwidth with frequency. So bandwidth generally defined as is equal to f2 minus f1. So here f2 is the upper cutoff frequency, f1 is the lower cutoff frequency, and negative feedback decreases the lower cutoff frequency. Negative feedback decreases the lower cutoff frequency, and the lower cutoff frequency of an amplifier with negative feedback is given by bandwidth is f2 minus f1 by f1. Okay, and while coming to the next one, so effect of negative feedback on input impedance. How it will affect the input impedance? How the negative feedback will affect the input impedance? So the effect of negative feedback on the input resistance depends upon the type of mixing. Type of mixing means whether maybe positive is connected to the positive or positive is connected to the negative. So here the negative feedback, how it will affect the input impedance? How it will affect the input impedance? Or which parameters will affect the negative feedback? Okay. So here the effect of negative feedback on input resistance depends upon the type of mixing. So here already we read about mixings, whether it may be voltage series mixing or voltage shunt mixing or current series mixing or current shunt mixing. That indicate what's whether it may be series mixing or it may be shunt mixing. If it is the series mixing, it increases the input resistance by a factor of A beta 1. Okay, the series mixing increases the input resistance by a factor of A beta 1. And the shunt mixing will decreases the input impedance by same factor. Listen here. So there is a slight difference between the series mixing and shunt mixing. The series mixing increases the input resistance by a factor of A beta 1. How much the input resistance is increased by series mixing? By A beta 1 factor. So series mixing will increases the input resistance by the factor of A beta 1. Next, while coming to the shunt mixing will decreases the input impedance. Series is increases, shunt is decreases the input impedance by the same factor. Okay, the effect of negative feedback on the input resistance will depends upon the type of mixing. Okay, so in type of mixing, the series mixing will increases the input resistance by a factor of A beta 1. So here A indicate what's gain, beta indicate what feedback factor, A indicate what's gain and beta indicate what's feedback factor. And shunt mixing decreases the input impedance. Shunt mixing, okay, decreases the input impedance by the same factor, it will decreases. Okay, so in this way the negative feedback, if it is having series mixing, it will increases the input resistance by a factor of A beta 1. If it is the shunt mixing, it will decreases the input impedance by the same factor. Okay, and see here While coming to the effect of negative feedback on the output impedance. So we learned about now effect of negative feedback on the gain is over, and effect of negative feedback on the bandwidth is also over. Effect of negative feedback on the input impedance is also over. Next important factor is effect of negative feedback on the output impedance. Okay, impedance means what? It's also the indicates resistance. Okay, so here the negative feedback will affect the impedance based on the type of sampling. How it will affect? How the negative feedback will affect the output resistance? So how it will affect? Due to which region or which factor it will affect the output impedance means cause of sampling. In feedback, we are going to do the sampling now like this. For example, this is the amplifier circuit. So feedback means connecting fraction of output back to the input. So this is the output and this is the input. This is the sampling network. So why we are moving with samples? The fraction of output only connected back to the input now. Fraction of output connected back to the input. Only fraction of output is connected back to the input. So how can we are getting fraction? From the whole. This is the whole. From this whole, how can we are getting the fraction? Cause of only sampling network. So sampling network, internally it consisting of resistors and capacitors, inductors. Okay, so cause of these resistors, capacitors, inductors, it may will affect our whole resistance. So in this way, the negative feedback will affect the output impedance cause of sampling. What is meant by sampling? Collecting fraction of outputs from the whole output is called sampling. Here, how the sampling will affect? So while coming to the voltage shunt, voltage series, current shunt, current series, samplings are of two types. One sampling is called current sampling, other one is called voltage sampling. So here, current sampling will increase the input resistance. Okay, what is happened here? Current sampling will increase the input resistance by a factor of A beta 1 plus 1. Okay, what happened in current sampling? Current sampling will increase the input resistance by a factor of A beta 1 plus 1. And the voltage sampling will decrease the input impedance by the same factor. So what happened here? Current sampling will increase the input resistance and the voltage sampling will decrease the input impedance. Is it clear? So while coming to the effect of feedback on the output impedance will be affected by the negative feedback. So how it will affect means due to sampling. What is the cause for affecting of feedback and output impedance? Reason is only the sampling. Okay, so cause of sampling, it will affect the output impedance. So samplings are of how many number of types of samplings are there here? Two types of samplings are there. Current sampling is there as well as voltage sampling is there. Here current sampling increases the input resistance by a factor of A beta 1 plus 1. And the voltage sampling will decreases the impedance by the same factor. Is it clear? And while coming to the next one, advantages of negative feedback. What is our next topic? Advantages. So it will increase the stability. What is the first and prime advantage? It will increases the stability. And also it will increases bandwidth. Increases stability, increases bandwidth. And here the amplitude is less, very less amplitude is there here. And also disturbance is there, harmonic distortion is there. Is it clear? What is the main advantage? Increases stability. And while coming to the next one, bandwidth also increased, and the amplitude is very, very less, and harmonic distortion is also less, and noise also will be reduced, decreased noise, and less frequency distortion is there, frequency distortion also less. So here what is the main advantage is distortion is less, stability is less, that is not an advantage, but stability is high, that is the advantage. Why we are going to getting high stability means disturbances will be reduced, distortion will be reduced, noise will be reduced. So cause of these factors, the circuit will become stable, circuit becomes stable. And see here, while coming to the next one, power amplifiers. What is meant by power amplifier? What is our next topic? Power amplifier. What is our power amplifier? Here, of course, it is a transistor amplifier which raises the power level of the signal in audio frequency range. Okay, what is meant by general amplifier? It is a device which is used to increase the strength of a weak signal is called what? Amplifier. What is meant by amplifier? It is a circuit or it is an electronic device which is used to increase the strength of weak signal is called amplifier. And while coming to the power amplifier, of course it is an amplifier which raises the power level of the signal, which raises what? Power level of the signal in audio frequency range, not radio. So what is the range of audio frequency? What is the audible range? 20 Hz to 20 kilohertz only. What is the audible range? 20 Hz to 20 kilohertz. So if in the audio frequency range, we will raise the power level of the incoming signal. It's not a voltage or it's not a current level, which raises only the power level. That amplifier is called power amplifier. What is meant by power amplifier? It is an amplifier which raises the power level of the audio frequency signal. What is meant by audio frequency? 20 to 20 kilohertz signal is called audio. If an amplifier raises the power level of the signal in audio frequency range, then that is called transistor power amplifier. One more definition is also there, means one more method is also there to define power amplifier. What is that method is? Power amplifier is also simply converter. Why it is called means which converts DC power to AC power. It's not a rectifier. Why? Because it's not converting from AC to DC. Which converts from DC to AC. Which action is controlled by the input signal? Is it clear? Power amplifier may also defined as, sometimes it also defined as, it's a device which converts DC power to AC power, which converts DC power to AC power, and whose action is controlled by the input signal, and whose action is controlled by the input signal. So these are the two different definitions. In two ways we can define the power amplifier. What is meant by power amplifier? It is an amplifier or it is a transistor which raises the power level of signal. How many number of levels are there for one signal? Voltage level is there, current level is there, power level is there. If we raise the power level of the signal, then that is called only power amplifier. Under one condition. What is the condition? We raises the power level of the signal in audio frequency range. In which range? In audio frequency range. Then only it is called transistor amplifier. Is it clear? Then only it is called transistor power amplifier. And while coming to the next way, we can also define it as it is a device which converts DC power to AC power, which converts DC power to AC power, and whose action is controlled by the input signal, whose action is controlled by the input signal. And see here, it's having the capability of providing large amount of power to the load. What is the main capacity of power amplifier? What is the main capacity of power amplifier? Which provides large amount of power to the load. So what is the load here? We are using here loudspeakers or motors. Okay, mainly the power amplifier used as an input for the loudspeaker or the motor, so that this amplifier having the capability of providing large amount of power to the load, such as loudspeaker or motor, etc. The power amplifier is also called large signal amplifier. It is also called what? Large signal amplifier. And it is essential in almost all electronic systems where a large amount of power is required to be supplied to the load. Okay, if we are working in audio systems, auditoriums, so there is a need of raising our voice signal. Okay, so to increase the level of voice signal, first we will convert our voice signal into power signal. Okay, first we will convert. Why? Because already we said audio frequency signal. So audio frequency signal means 20 to 20 kilohertz signal. Initially it is converted into electric signal. Then in this electric signal, power level must be raised. So and then it is given to the input of loudspeaker, or it is a motor. So finally, where we are using the power amplifiers? Power amplifiers maximum in almost all cases we are work with loudspeakers. And where it is used? Last stage in the electronic system. Already I said this. 20 to 20 kilohertz audio frequency signal is a sound signal, or it may be voice signal. Okay, this is a non-electrical signal. So first we would like to convert this non-electric signal into electric signal. Then only we convert this electric signal into again sound signal, but after increment of its level, power level. Before again we convert it into the sound signal, first we would like to raise the level of this signal. Then only given to the electronic system. So that power amplifiers used in front of loudspeakers, where the loudspeakers occurred means at last stage of electronic system, where we are getting in the last stage of electronic system. Power amplifiers are used in front of loudspeakers. So the stage is last stage in the electronic systems. So this is about what is meant by power amplifier, and where we are using, and what it is also known as. What it is also known as audio amplifier. Why it is also known as audio amplifier? Why? Because power amplifiers will raise the signal strength. The signals fall in the range of 20 to 25 kilohertz, means audio frequency signal only. And while coming to the application orientation of power amplifiers, these are used in public addressing systems like tape recorders, television receivers, radio receivers, broadcast transmitters, etc. Where we are using these amplifiers? We are using in public addressing systems, tape recorders, television receivers, radio receivers, broadcast transmitters, etc. Is it clear? So what is meant by power amplifier? It is a circuit which is used to increase the strength of signal that is in the power level only. And it is essential in almost all electronic systems where a large amount of power is required to supply the load. And the power amplifiers are used in the last stage in the electronic systems. And these amplifiers is more commonly known as audio amplifiers. And the power amplifiers are used in public address systems. What are the public address systems? Sound systems, auditorium halls, seminar halls, and also used in tape recorders, television receivers, radio receivers, broadcast transmitters. All these are the applications we are using the power amplifiers. What is the other name for power amplifiers? These are also called what? Audio amplifiers. Why these are also called audio amplifiers? The range of power amplifiers lies in between 20 to 20 kilohertz. So see here voltage amplifiers, while coming to the difference between the voltage and power amplifiers are a voltage amplifiers having the gain value, that means beta, about 100. What is the gain of voltage amplifier? 100. But while coming to the power amplifier, compared to the voltage amplifier having less gain, that means the beta value is lies in between only 20 to 50. So compared to voltage amplifier, the gain of power amplifier is somewhat less. Okay, here voltage amplifier having the gain value is about 100, but here the power amplifier having gain in between 20 to 50. And here the load resistance RC having the high value is about 10 kilo ohms. Load resistance having the high value about how much? 10 kilo ohms. And the load having the small value 10 ohms to 20 ohms only. Why the power amplifiers having only 20 to 10 ohms? Why should the gain also having less than here? But in voltage amplifiers, much more gain is there. So to transfer that gain from one stage to other stage, it must be done with help of high loads, 10 kilo ohms. And here the input voltage is low, approximately few millivolts only. Means voltage amplifier will give, with low input it will give high inputs. But power amplifier having high few volts. And in a voltage amplifier, low power output is there. Why? Because it is a voltage amplifier now. So that here power output is very, very low. But in power amplifier, power is high and voltage is low. In collector, current has low value, 100 milliamperes only in voltage amperes. But while coming to the power amplifier, much more collector currents are there. And in voltage amplifier, output impedance of voltage amplifier is very, very high. Why? Because it is an voltage amplifier which will raise the strength of voltage level only. But in power amplifier, voltage level is less. Because of its output impedance is also very, very less. In voltage amplifiers, usually RC coupling circuit is used. But in power amplifiers, transformers or tuned circuit is used. In voltage amplifiers, only RC coupling is used. But in power amplifiers, transformer or tuned couplings are used. Okay. And see here, this is the block diagram of power amplifier. While coming to the block diagram, how many number of stages are there in the block diagram? 3 stages are there. What are the 3 stages? Voltage amplification stage, driver stage, output stage. Okay, how many number of stages are there? Voltage amplification stage, driver stage, output stage. So in voltage amplification stage, input is applied, means the voltage amplifier amplify the input signal. Then it will be given to the loudspeaker after increasing its power level. After increasing its power level, it is given to what? After increasing its power level, it is given to last stage, that is output stage. Here we are using loudspeaker when it is given through only driver stage. Okay, through driver stage only we given. See here, there is a small discussion already. I told you in slide it is there. In power amplifier is to amplify a weak signal, okay, having 3 levels. Voltage amplification stage is there, driver stage is there, output stage is there. How many number of levels are there? 4 levels. Voltage amplification stage, driver stage, output stage. Already we seen it in our block diagram. Okay, and see here, while coming to the small description, already I said you amplification stage is having amplifier. Okay, and this amplifier will increase the voltage amplification to the input signal. In amplification stage, what we are having? Amplifier. Okay, and how much it is level? Less than 10 millivolts. And the purpose of voltage amplification is to provide necessary voltage amplification to the input signal. And here usually the voltage amplification stage consists of 2 or more RC coupled amplifiers. How many number of amplifiers are there? 2 or more RC coupled amplifiers. And next one is what? Driver stage. So here it is already, we seen it in block diagram. It is placed in between input and output stage. Where it is placed, where the driver is placed, it is between input and output stage. What is the theme of this driver? The purpose of driver is to provide power gain. It acts like a power amplifier. This is very, very important stage. So here it is what? Power amplifier. It is placed in between input and output. It is used to produce the power gain, and this stage generally implies class A transformer coupled amplifier. So which type of amplifiers we are using here to produce the power level? Class A transformer coupled. So class A provides 0 to 360 degree phase shift, and transformer coupled means here transformers are used to connect the output of one stage to the next stage. And also the input impedance matching circuits are used to connect the output to the next one. And see here, while coming to the output stage, whatever the output or the power signal we are getting from the driver stage, that is connected to the output stage to the output stage. And means it is directly, the signal is connected to the loudspeaker without any disturbance. And this output stage gives the improvement of power gain again by reducing the loss. Means if is there any distortion or disturbance signal is there, that must be eliminated with help of output stage. Then what it contains? Class B amplifier. The output stage is invariably transformer coupled, and it employs class B amplifier in push-pull arrangement. What is the need of push-pull arrangement means? Cause of push-pull arrangement, the unwanted voltages must be eliminated. Unwanted voltages will be eliminated. And see here, while coming to the classification, the power amplifiers like our general amplifiers are classified into class A power amplifier, class B power amplifier, class AB power amplifier. What are the 3 main types? Class A power amplifier, class B power amplifier, class AB power amplifier. And class C power amplifier is also there. While coming to the class A power amplifier, it will produce the current in all times. Okay, means for positive half cycle it will produce, for negative half cycle also it will produce. But in class B, it will produce the amplifier signal or the output signal for only positive half cycles. It will produce the signal for only positive half cycles. In class B, it will produce the output for more than positive half cycle and less than negative cycles. And while coming to the class C, less than half cycle only. It will provide for positive and negative. It will provide only for the positive half cycle. It will provide greater than positive and less than negative. And it will provide less than half cycle. So this is about class A, class B, class AB and class C. And while coming to the efficiency is defined as AC power output to average DC input power, output to input. And in power amplifier, it is also called conversion efficiency. And the efficiency of an amplifier represents the amount of AC power delivered or transferred to the load from DC source. Why? Because it is also called DC to AC. AC power delivered or transferred from DC source. See here, while coming to the distortion, the disturbance signal is called what? Distortion. So here the distortion, how it will occur means, the possible distortions are in the fashion of frequency phase. Okay. So this is about what? Distortion. Distortion means disturbance signal. The faithful amplification, the output signal must be a scaled replica of the input signal. Okay, so now we are discussed about what is meant by power amplifier, what are the different types of power amplifier, what is the difference between voltage and power amplifier, and what is the block diagram of power amplifier. Okay, so now I would like to conclude the class. In next section we will meet you again.